Good morning, students and viewers. Welcome to my YouTube channel, The Diligent Coaching Seminary. This is an academic YouTube channel in which I upload different tutorial videos based on the courses of the schools and colleges. And today, once again, I have come here with a new video. And in my previous videos, I have been giving you the lecture for the class 10 students in the subject of science. And today once again I have come here to give you the lecture in the subject of science for class 10 students. And in science I have been giving you the lecture of the chapter force, and today once again I have come here with the 8th part of the lecture for the force chapter of class 10. So now let's start to study the remaining topics of the force chapter. In my previous videos of the chapter force of class 10 science, I have already given you all the enough concept about whatever theory you have to study in this chapter. You have studied about the gravitational force, force of gravity, acceleration due to gravity, and similarly you have studied about the free fall, weightlessness, mass, weight, and different topics. So now today in this 8th part of the video I have come here with the necessary numerical problems that will be asked in your examination. So let's see some numerical problems that can be asked in your examination. And here first numerical problem, you can see whatever I have mentioned here. The question is, calculate the gravitational force between two objects having masses 10 kg and 15 kg and separated by distance 100 meter. So in this question has given masses of two objects. Mass of the first object is 10 kg and mass of the second object is 15 kg. Then distance between those objects is given 100 meter. Now we have to find out the gravitational force between these two objects. And you know the formula of the gravitational force is obtained from the Newton's law of gravitation, and the formula of gravitational force is g m1 into m2 by d square. So that formula should be applied here. So first of all, here we have to write all the given factors whatever are given. Mass of the first object is given 10 kg, so that is m1, and mass of the second object, that is m2, it is given 15 kg, and distance between the objects d equals to 100 meter. And we have to use here the universal gravitational constant, and the value of universal gravitational constant capital G is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Now gravitational force F equals to what? And now we know the formula of the gravitational force. We know that F equals to g m1 into m2 by d square. This is the formula of the gravitational force. So exactly this formula should be used here. F equals to g m1 into m2 by d square. And now let's put the value of g m1, m2 and d, and here in the place of universal gravitational constant g we have written 6.67 into 10 to the power minus 11. It is the value of g. Then value of m1 is 10 kg, so we have written here 10, and value of m2 is 15 kg, so it is 15. And in value of distance d is 100 meter, so in the place of d square we have written 100 square. Now here first of all we have multiplied these numbers. We have multiplied 10, 15 and 6.67. Okay? These three numbers are multiplied here. 6.67 into 10 into 15, and 6.67 into 10 into 15, it will be this 1000.5. So by multiplying these three numbers we obtain 1000.5, and into 10 to the power minus 11 it is written as it is, and 100 square is 10,000. Now after this, in the place of 1000.5 we have written as it is, and 10 to the power minus 11 again as it is. Then now in another Here in the place of 10,000 we have written here 10 to the power 4. You know 10,000 can be written 10 to the power 4 because here is 10 to the power minus 11, so we are expressing this in the form of 10 to the power. And now again we have written 1000.5 as it is, then here is 10 to the power minus 11 and here is 10 to the power 4, and you know by the law of indices then this power 4 will be as subtraction when it is taken to the numerator. It is from the law of indices, so it will be 10 to the power minus 11 minus 4 and it is obtained 10 to the power minus 15. So here we have obtained 1000.5 into 10 to the power minus 15. And to now here to write the scientific notation, you know the decimal should be shifted to left side, and here decimal is shifted to left side by 3 digits, and we have written here 1.0005. so since decimal is shifted left side by 3 digits, so here 10 to the power minus 15, it should be decreased by 3, and now it should be 10 to the power minus 12 Newton is obtained. So here we obtain the answer F equals to 1.0005 into 10 to the power minus 12 Newton, and this is the required gravitational force. Therefore, the gravitational force of attraction between those two objects is 1.0005 into 10 to the power minus 12 Newton. So this is one for a numerical question we have done. Now let's see another numerical. And here in the another numerical, the question is like this. If mass of the moon is 7 into 10 to the power 22 kg and it is 3 into 10 to the power 8 meter away from the earth, then calculate the force by which moon pulls every kilogram of water of the Pacific Ocean to cause tide. So in this question it has given mass of the moon, that is 7 into 10 to the power 22 kg, and it also has given mass of the water, because question has said calculate the force by which it pulls every kilogram of water. That means mass of the water which should be pulled by the moon is 1 kilogram. Question has said every kilogram of water, and distance between moon and the water is obviously it has given 3 into 10 to the power 8 meter. So it is the distance between moon and the water, because water is located in the earth. Then universal gravitational constant, its value is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Then now here we have to find out the force by which the moon attracts every kilogram of water of the Pacific Ocean, and that is we have to find out the gravitational force, or simply we can say we have to find out the gravity. And you know the force of attraction, the formula which should be applied here is F equals to G capital M small m upon R square. This is the formula of the gravity. And now we have put all the values here. Value of the G is 6.67 into 10 to the power minus 11. Then value of capital M, mass of the moon, is 7 into 10 to the power 22. Then mass of the water, small m, it is 1 kg, so we have written here 1, and in the place of R square, that means distance, it is 3 into 10 to the power 8 square. Now let's see the further step. Then now first of all we have put 6.67 and 7 together in the numerator. Numbers should be always put together like this. So 6.7 into 7 together, then 10 to the power together. Here 10 to the power minus 11 and 22 is here. So here we have written 10 to the power minus 11 plus 22. Now here in the denominator we have to do the squaring of 3 and 10 to the power 8 both, because here is 3 into 10 to the power 8 whole square. So here 3 square is obtained 9 and 10 to the power 8 square is 10 to the power 16. Then now here we have multiplied 6.67 into 7 and it is 46.69. 6.67 into 7 is 46.69 and upon 9 is written here separately. The numbers are again separated here, and here is 10 to the power minus 11 plus 22, it will be 10 to the power 11 in the numerator, and in the denominator 10 to the power 16 as it is. And now you know this 10 to the power 16 power is here in the denominator and it should be subtracted by the law of indices. Then 46.69 divided by 9, it is obtained 5.187. And now we have to do 10 to the power minus 10 to the power it is 11 minus 16, and 10 to the power 11 minus 16 is, it is obtained 10 to the power minus 5. And so here we have obtained the force F equals to 5.187 into 10 to the power minus 5 Newton, and it is the required answer. And therefore the moon attracts every kilogram of water of the Pacific Ocean by the force of 5.187 into 10 to the power minus 5 Newton. So this is the another numerical we have seen. Now let's see another numerical which can be asked in your examination. And the numerical is like this: two spherical objects having diameters 8 centimeter and 12 centimeter and are placed joining each other. If the mass of those objects is 100 kg and 200 kg respectively, then calculate the gravitational force of attraction between them. So in this question, first of all, it has given mass of first object m1 equals to 100 kg and mass of second object m2 equals to 200 kg. And now diameter of first object is given 8 centimeter and diameter of second object is given 12 centimeter. And when those two objects are placed by joining each others, that means they are placed each other by joining their surface, then the distance between the center of those two objects will be the addition of their radius. That means we have to add the radius of both objects, then we will obtain the distance between the center of those objects. So here we have to find out the radius of both objects, and radius of first object r1 equals to diameter of first object d1 upon 2, radius equals to half of the diameter. Then so radius is obtained 4 centimeter because diameter of the object first is 8 centimeter, so radius is obtained 4 centimeter of the first object. And radius of second object r2 equals to diameter of second object d2 upon 2, and diameter of second object is 12 centimeter, so it is 12 upon 2 centimeter is the radius of second object, and radius of second object is 6 centimeter. So since radius of the object equals to half of the diameter, we have obtained here radius of the first object is 4 centimeter and radius of the second object is 6 centimeter. Now by the common sense, the distance between the center of those two objects will be the sum of their radius. So the distance between their center will be radius of first object plus radius of second object, and it will be 4 centimeter plus 4 centimeter, it is 10 centimeter. So 10 centimeter is the distance between those two objects center. And then here we have to use the universal gravitational constant G equals to 6.67 into 10 to the power minus 11 Newton meter square per kg square. Then now here we have to find out gravitational force between them, F equals to what? And we know the formula, we know that F equals to G m1 into m2 by d square. And we have put all the values, that is value of G is 6.67 into 10 to the power minus 11. Then value of m1 is 100 kg, question has given this value, and value of second object mass, it is 200, this also question has given to 200 kg is the mass of second object. Then distance between their center, just before we have found out, that is 10 centimeter, then it is 10 square. And now here after here we have to do the squaring of 10 in the denominator. So 10 square equals to 100 is written here, and 100 and 100 will be cancelled here. 100 cancelled. Then now we have multiplied here the numbers, and by multiplying the number, now here we have to multiply 6.67 and 200, and 6.67 into 200 will be 1334. And now to write in the scientific notation, you have to write 1.334, and when we write 1.334, then decimal is shifted by 3 digits in left side. So negative power of the 10 should be decreased by 3 here. So here we have written 10 to the power minus 8 because here decimal is shifted left side. by 3 digits. So 10 to the power should be decreased by 3 in the negative power of 10, and it is obtained 10 to the power minus 8 Newton. So the required gravitational force between those two objects is 1.334 into 10 to the power minus 8 Newton. So only one thing you have to understand in this question that I want to revise to you, that is, the question has given the mass of two objects, 100 kg and 200 kg, that is m1 and m2, and the question has given diameters of those two objects, and from the diameter first of all we have to find out the radius of the objects. And since the question has said those objects are placed by joining each other, then distance between those two objects center will be the sum of their radius. So we have to find out the radius of both objects by applying the formula radius equals to half of the diameter, r equals to d by 2, radius equals to diameter by 2. Then after finding the radius, we have to add the radius of both objects to find the distance between center of those two objects. And after finding the distance, then simply we have to use the formula of the gravitational force, that is F equals to g m1 into m2 by d square. And from this formula we obtain the required answer, required value of the gravitational force. Now let's see the next numerical question. The question is, if the radius of the earth is 6 into 10 to the power 6 meter and the value of acceleration due to gravity is 9.8 m per s square, calculate the mass of the earth. So here question has given radius of the earth, that is 6 into 10 to the power 6 meter, and acceleration due to gravity is given 9.8 m per s square. And now we have to use here the universal gravitational constant g, that is 6.67 into 10 to the power minus 11 Newton meter square per kg square. And here we have to find out the mass of the earth, capital M equals to what. And to find the value of mass of the earth, we have to use the formula of acceleration due to gravity. Formula of acceleration due to gravity is small g equals to gm by r square. This formula should be used. And since we have to find out the value of capital M here in this numerical mass of the earth, so by the law of equation we put just mass at left side capital M, and now it is obtained capital M equals to g into r square by capital G. So this is the formula of mass we have obtained by the law of equation here. Now we put the value of all small g, capital R and capital G, because all these are given here in this question. And by putting the value we obtained, now here value of small g, it is value of small g is 9.8, that is what we have put here, value of small g. And value of radius r is given 6 into 10 to the power 6 whole square. Then value of capital G, gravitational constant, is 6.67 into 10 to the power minus 11. Now first of all let's do the squaring of 6 into 10 to the power 6 whole square. And here is 6 into 10 to the power 6 whole square is here, so we have to do the squaring of both. Squaring of 6, it will be 36, and squaring of 10 to the power 6, it will be 10 to the power 12, and 9.8 is written as it is. Then in the denominator 6 into 10 to the power minus 11 is written as it is. It is the value of universal gravitational constant in the denominator, 6.67 into 10 to the power minus 11. Now we have to multiply 9.8 and 36, and 9.8 into 36, it will be 352.8, and 10 to the power 12 written as it is. Then 6.67 into 10 to the power minus 11 written as it is in the denominator. Now we have to separate the numbers and 10 to the power. So here we have written 352.8 upon 6.67, and into here is 10 to the power 12 upon 10 to the power minus 11 here together. So numbers together and 10 to the power together. Then 352.8 upon 6.67, it will be 52.89. And here 10 to the power 12 upon 10 to the power minus 11 is here, and by the law of indices this 10 to the power minus 11 should be added here in the power of 10 in the numerator. So here we have written 52.89 as it is, then 10 to the power 12 plus 11 powers are added here. Then here we obtain 52.89 into 10 to the power 23. It is the value obtained here. Then now this decimal should be shifted to left side by one digit, and we have written here 5.28. And when decimal is shifted left side by one digit, then positive power of the 10 should be increased by 1, because we have shifted the decimal left side by one digit. So in the place of 10 to the power 23, we have written here 10 to the power 24, and so the value of capital M equals to 5.28 into 10 to the power 24 kg, and it is the required value of the mass of the earth. Therefore the mass of the earth is 5.28 into 10 to the power 24 kg. So here mass of the earth is obtained by using the formula of the acceleration due to gravity. Now let's see another numerical question, and the numerical question is like this. The question is, calculate the acceleration due to gravity of the top of the mountain, assuming that altitude of the Mount Everest is 8,848 meter from the sea level, and the radius of the earth is 6.4 into 10 to the power 6 meter, and mass of the earth is 6 into 10 to the power 24 kg. You can see here, first of all, it has given mass of the earth capital M equals to 6 into 10 to the power 24 kg, and radius of the earth r equals to 6.4 into 10 to the power 6 meter. It is 6 4 and 1 2 3 4 5 0. So here we have obtained 64 lakhs meter is the radius of the earth. Then height of the mountain s equals to 8,848 meter. This also has been given. Now here universal gravitational constant g equals to 6.67 into 10 to the power minus 11. It should be used. Then now you know the formula of acceleration due to gravity at the certain altitude. It is not gm by r square, it is gm by r plus h square. This is the formula of acceleration due to gravity at altitude h. So this is the formula of acceleration due to gravity as altitude h. So g equals to gm by r square. It is the formula of acceleration due to gravity at height h. Then now let's put all the values. Value of capital G, it is 6.67 into 10 to the power minus 11, and value of capital M, mass of the earth, it is 6 into 10 to the power 24, and you know capital R, radius of the earth equals to, it is 64 lakhs, and height of the Mount Everest, it is 8,848. In this height we have to find out the value of the acceleration due to gravity. Now what we have done here in the second step, we have kept numbers together, 6.67 and 6 together, and 10 to the power minus 11 and 10 to the power 24 together. This is the way to do. Now here first of all we have added 64 lakhs and 8,848, and here we have obtained it is 64 lakhs 8,848 and square, and squaring 64 lakhs 8,848, it is obtained this much value in the denominator. And in the numerator now we have multiplied 6.67 and 6, it is obtained 40.02. Then here 10 to the power minus 11 and 10 to the power 24. Then you know by the law of indices we have to write here 10 to the power minus 11 plus 24. And 10 to the power minus 11 plus 24, it will be 10 to the power 13. That is what we have obtained. And again we have kept 40.02 upon the number in the denominator. 40.02 divided by this number, it is obtained here. You can see in the another step, this 40.02 divided by this, it will be 9.74 into 10 to the power 13. This is the value obtained by dividing 40.02 upon 41073332687,104. It is obtained 9.74 into 10 to the power minus 13, and here 10 to the power 13 of this step is written here as it is 10 to the power 13. This is the value obtained by dividing this, this whole value 9.74 into 10 to the power minus 13 is obtained by dividing this. So value of this whole part is this. Then 10 to the power 13 is written here 10 to the power 13 as it is. Then you know 10 to the power minus 13 plus 13 should be written here by the law of indices. Then 9.74 is written as it is. Then you know it will be 10 to the power 0. then 10 to the power 0 is 1, so 1 should not be written, so it is only obtained 9.74 in only. And it is the value of acceleration due to gravity, so its unit is meter per second square. So the required value of the acceleration due to gravity at the top of the mountain is 9.74 meter per second square. This is the required value.